organising afternoon panel session. So we have four very distinguished individuals who I'm sure would be happy to give you the benefit of their wisdom and knowledge, but a lot depends on you. Okay, so if you ask no questions, if you will, if you're very quiet, then the panel session will be very short. If if you contribute, ask questions, provoke discussion, then we hopefully have a good debate. So before we start, can I just ask the panel just to introduce themselves, just so that everyone knows who they are. So if we start with Georgios and then go on. So.
All right, my name is Georgios Giannakis. I am a faculty member with the Department of Electrical and Computer Engineering at the University of Minnesota. And I also serve as director of a research unit there that we call Digital Technology Center. My research interests have spanned, I change an area almost every 8-9 years. I did a lot of work early on statistical signal processing theory and algorithms. Moved on to wireless communications and networking. And these days I do what people refer to on the analysis side, big data, and on the umbrella application, what they call network science, as they apply to power networks. Smart grid is an example, but also brain networks as well as social networks. Thank you.
Good afternoon. My name is Ari Polto. I come from Finland, Sub-Zero man. I've been with the University of Oulu for 20 years, and I've been doing a lot of different kind of research projects, starting from radar, going to military communication systems, positioning systems, and lately cellular systems, LTE, and now 5G. And I run currently a small team at the University of Oulu, which is looking at dependable wireless communications. And of course, critical infrastructures in general are the ones that need dependability, reliability, low latency, and that kind of things. And we are looking at, of course, wireless communication solutions, as I come from the wireless communication unit. So, even though I'm going to soon talk about the smart grid project, please bear in mind that I'm a wireless guy. Thank you.
My name is Antonio Gomez Esposito. I am professor of electrical engineering at the University of Seville. I've been working for over 33 years on power engineering, just power engineering, both transmission distribution levels. I am currently, also director of the Endesa chair. And I think that's all. I think
My name is Manuel Jesus Tellechea. I work for Enel, to the Network Technologies Department in the Infrastructure and Network Division. Enel is the Italian utility. I've been working for the last 5 years in the smart metering project in Endesa, the deployment of the smart meters, mainly concerned with the standardization activities and participation in a European project related with information gathered with the smart metering system. And well, I'm not being involved directly in smart grid issues, but as the smart metering infrastructure are considered the basis of the smart grids, I suppose that's why I'm here.
Right, okay, so I've put on, I think conveniently for a panel, they can't see the questions, but I'm going to begin with the first one, so yeah. So
we can see it.
So maybe if I start with Georgios and just ask you very briefly, if I say the word smart grid to you, how do you understand by the smart grid? So let's talk about its definitions or the understanding of what smart grid really means, or what will change if you implement the smart grid.
smart grid as I tried to outline in my, I also, let me see,
Doesn't
can you
work.
hear me?
No, it doesn't work. It doesn't work.
Let me try that one.
Hello? I think that's better, right? Okay. So as I mentioned during my talk yesterday, it is difficult to come up with definitions, but what is universally acceptable is all the advances, both technological as well as research advances, that equip the aging infrastructure of the power grid with state-of-the-art information and system-level technologies to render this aging infrastructure having the desirable features of being controllable, green and efficient, and participating from all parties involved, as well as self-restoring and sustainable. This is the definition and the desired features of what people like to call the smart power grid. So in a nutshell, the power infrastructure upgraded with advances in hardware and information technologies. That's the definition I would say is widely acceptable.
Good. Anyone else want to add?
Well, I guess there are as many definitions as there are people who are defining it. I talked to this guy in Finland who is a development manager at distribution system operator company, which I leave unmentioned here. To his mind, smart grid was a system that would allow them to save 4 to 7 million euros in burning oil, because in that particular city there is a district heating system, and during the really cold days they need to burn some oil to get more energy than the normal systems provide for the district heating system. And to him this was the ultimate smart grid, to save 4 to 7 million euros in oil. But I guess on the other side of the spectrum, they're basically the smart grid would mean any technologies, any advances that will improve energy efficiency all the way from the generation to the point of use. Because currently, from the primary source, when energy is in the socket, we've lost 75%, so there is a lot of improvement there. And as we go to the power grid, I guess what the Giorgio said here previously, those basically define the smart grid in real life. So that's from me.
Well, there are formal definitions of smart grids. Actually, the European platform for smart grids provides, you can find in the internet the documents by this platform. The definition is very close to what Professor Giannaki has just said. It's in summary, the power grid reinforced, enhanced with IC technology layer and sensors and software or hardware. That's a computer. So that's the smart grid. But I think this is somewhat misleading. Why have not called smart grids those that have been around for the last 125 years? I don't know why. Because smart grids have been smart since the very beginning. Since Edison deployed the first electrical installation in New York. By the way, they were using cogeneration that we are not using so much as we should. So they were using analog protected devices. So electrical systems have been adopting all technological advancement in the 20th century. For instance, just to name three of them, very important for to justify, to understand the way power systems are today. For instance, in the first 2 decades of the 20th century, we adopted very huge steam turbines. These very huge steam turbines justify other reasons why we have this giant interconnected international network interconnected at the top level, at the very high, ultra high voltage level. So that's because we have 1,000 megawatts station that has to deliver all this energy to the load center, which are remotely located. That's why we have so densely meshed networks or transmission network. So this is a development that was the electricity price decreased significantly, several orders of magnitude because of this development. So this is a smart network. Another example is in the 60s and 70s in the 20th century, we introduced the energy management systems. We introduced digital computer at the beginning, shared with analog computers, network simulator, network analyzer that were on the stage before. So we were adopting digital computer. Probably one of the first applications, except for military application, was on power network to supervise, to monitor, to control, to optimize, to plan in a smart manner power system. And later on, we introduced renewable in the 20th century, late in the 20th century. Before the formal name of smart grids arose, before that, transmission systems were already using intelligent electronic devices, which are digital protected devices. Most transmission substations were digital before the smart grid concept arose. So why do we call this? Why? Because we have smart meters and synchrophasor. That's the reason. The only reason why we call smart meters today, smart grid today. Were not then smart earlier? I don't think so. I think this is a fashion. This is in fashion. This is like sustainability, like all those popular words nowadays. Basically, because some huge companies like IBM and those, they were interested in looking for alternative business model, business niche. So that's the reason. That's all. That's why we are all here, basically. So grids has been always as smart as the current technology allows. My definition for smart grid is the one which uses the right technology at the right moment to allow delivery of electricity, high quality electricity at lowest cost. So it doesn't make sense to install a lot of smart meters if you don't use them. You are spending money for nothing. You know what? So this is my theory. And then I will elaborate further later on.
It's clear enough. Well, yeah, I agree that it's a fashion nowadays to put smart before anything. We talk about smart grids, smart meters, smart cities, smart cars, smart anything. That's true that it's fashion just to say anything is smart nowadays. And I agree also that the power networks, I've been working in power networks for the last 20 years, have been always quite smart. They have introduced the state-of-the-art technology, computers, telecontrol. I think they have been quite smart. But I think that now there are more possibilities. The technology is going one step further. I think that now the IT technologies, the new IT technologies, will provide new functionalities that were not, that years ago were not available. And now I think that the grids will be able to support new functionalities. We will be able to control or to manage the electric vehicle recharge, the renewables, distributed energy, things that nowadays is not easy to manage, and we will be able to manage that by introducing the state-of-the-art telecommunication and information technologies. And that's why we are talking about smart grids. And with these smart grids, we will build also smart cities. That is also another concept, maybe fashion, but I think it's a real concept. A smart city is something different than what we had before. And smart cities will be able to have them because we will have smart grids and smart meters and anything smart. Anything smart will build a smart world. I think it's different to make part of this. Everything is a whole composed of everything. We have to have a holistic vision of the smart world.
So before I ask my next question, is there any follow-up questions to the concept of so far? So if not, I think I'll have to be free.
I would like to comment on Antonio's vision. I guess a bit provocative.
It's siesta time, so I need to put your neuron to work.
So I agree with your vision if you just look at the generation and distribution of energy, but I think that there is something missing in this vision, which is the connection of this system to the rest of the world. So I think that the real innovation comes when you open the smart grid to the people. So there starts to be a connection between consumers and those generating the energy. So I think that here is where we are really the smart thing. So when we connect to the internet, the grid, so users can know which is their energy consumption, they can generate and they can add energy to the system. It's possible to add energy trading or some like P2P smart test where you see users selling energy and others buying energy. I think in this sense there is a huge revolution. So it's not just the way you operate the grid, which probably, I'm not an expert to that, but probably a grid that has been already smart for the last years.
Yeah, well, that's because we have this kind of gadget. I mean, you have this ubiquitous communication system everywhere, have a IP address, I mean, this Internet of Things and this kind of thing. You are right. I mean, we have many more different kinds of technologies to take advantage of to manage demand-side management, as Manuel Jesus said, electric vehicle integration, renewable integration, this kind of thing. But this is something, I insist, this is something that we always did. I mean, the problem is that we didn't have electric car 20 years ago. If we had had electric car 20 years ago, we had also integrated them even with another technology of those days. So I insist, we should forget and delete the word smart from everything, because all conferences I have been attending in the last 5 years, all of them, no exclusion, are smart something conference. I mean, the general meeting in the USA, all panel, all tracks, everything is smart, everything. So as everything is smart nowadays, including my glasses, and I mean, so forget about smart. Please.
Slightly away from the power system vision, because what would affect the Thompson power system? What do you think that the smart grid would bring to society in general? What is the benefit for society of implementing?
Good question. Good question. I have my own opinion, but probably other panelists may want to begin.
Well, I guess, shall we start with this question or the one that you posed? Because it's related, right? So if I understood correctly, your next question is on the
Benefits for the society.
the key enabling steps, right? And in my mind, one of them relates to the society. And what I would call that is the societal awareness on green energy and the adoption of the smart meters and the solar panels and the participation into demand response subscription and the transition that, for example, Germany has initiated in efforts to go from coal to wind and solar. So there is a need to be an awareness from the society and a participation of the society into it. Now, I can even go more specific. As I mentioned yesterday, for example, the moment that you are ready to accept higher penetration of renewables and reduce the dependence on crude oil, then you can go as far as, lowering the tension from the Middle East, right? That basically will not, the oil will not be as critical, the crude oil will not be as critical. So that would be, for me, society reasons is a key enabling factor. If I want to keep on my factors, I don't know whether the rest of the panelists want to add to the society, but they can do that afterwards. My second, the one that I could think of was innovation and investment in new technologies. And that is an effort that can start from utilities to companies such as Tesla and Google into green technologies. Nowadays, Google invests a lot of money into solving resource allocation problems with green technology. You cannot believe how much power these data centers consume. And transitioning in that is a critical enabling step in my mind. The third key point is the government. So the government needs to support by providing more tax breaks to encourage renewables, solar panel deployment, and the like. The fourth enabling factor in my mind is to mobilize what people refer to as economies of scale. So that refers to, for example, the battery costs that are now prohibitive, but new EVs make it into the market in big numbers, especially in a number of cities in the US that have pollution problems. So then policies and standards. This is something that I learned from the communications experience, that pretty much, for example, there is no stabilized standards to the communication protocols to be used in smart grids. And that's critical, I think. Furthermore, another enabling step that the Power Society is kind of behind is the facilitation of transitioning from an algorithm that you and I may have an idea to develop to a marketable product. Something like the generations of advances that the Comp Society defines, for example. That's not present, at least I'm not aware of, 5G-like advances or 6G down the road. I guess that's what I had. The policies that need to be changed. For example, what comes to my mind is that there are no policies made by regulators in order to adapt recent contributions that have been made by academic researchers as well as industry and national labs in the US. The policies are not established. So that aspect is also critical. So in summary, if I want to go back, my 7 I wrote enabling steps was society awareness, innovation and investment into new technologies, government support, economies of the scale, policies, standardization, and marketability. These are enabling steps for the smart grid to move it to its next level. It took too much time, I apologize.
No. That was basically
For the money.
Yeah.
That's what we say.
But I mean, there is smart and there is not smart. We use marketing words to in academia, for instance, to get money for our research, right?
Yeah.
So smart is there, self-organizing is there, cognitive is there. There are a lot of different words. In practice, when people have a hammer and an anvil and they are doing something with steel, they use whatever is available to them at that particular time. When we go to power grid, nowadays we have copper and aluminium, right, which we use for wires, right? Now, that doesn't mean that we should stop, for instance, looking at room temperature superconductive materials, right? So there is always this blue sky element to innovation which we need to also foster, because many of the inventions come from this blue sky stuff and not from, let's say, a very organized research where the companies are really setting the table for you. So there is also elements of surprise when you do research and you find something new So in that sense, I would like to at least have smart people when we do.
What's the new thing in the smart grid?
So that's my 5 cents.
Okay, I agree basically with what Professor Giannaki has summarized very well. So this enable for, but I think there was a question from the room, and I didn't answer because we are also focusing on the question by the chair of the panel. So going back to the question, how will society benefit from smart grids? I think that smart grids, I mean, the technology around, the new technologies around, power grids, which is called, in a simplified manner, smart grids, will succeed if they allow the society to fully decarbonize the energy consumption. If we are able to integrate 100% to all energy consumption in the future is 100% renewable, not only electricity, but also heating and transportation and the like, not only electricity. We will begin with electricity, but next step will be transportation and heating, etc. So if smart technologies are helpful to introduce or to decarbonize society at a reasonable cost, an affordable cost, something which is not very expensive, then this is the benefit we will get, because we need that. And in my opinion, to achieve this goal, ICT, information communication technology, will not be the main actor in this achievement. Will be rather energy storage, which is, in my opinion, the key point, not the ICT, not information communication technology. In my opinion, in order to achieve this goal, fully decarbonization and sustainable, really sustainable energy consumption for the future without depending on fossil fuel, is energy storage. In Germany, they have 40 gigawatts of wind energy, plus almost another 40 gigawatts of solar energy. Solar, there is no sun in the night, obviously, everybody knows. And wind, some days wind provides 2% of energy in one day, and other days wind provides almost 60% of energy in Germany. So it ranges from 2 to 60, over 60%. So we need the storage in the future. Well, it will be impossible to go on without this cheap and abundant energy storage system. So this is a key aspect. Probably for the next 50 years will be the main, by far the main major actor, main factor. More than ICT. For me, ICT will be improving, will continue. We will move from 3G, 4G, 5G, 6G, I don't know what. Changing frequencies and improving reducing the size of the energy consumption of this gadget or whatever. But this will be only a tool, not a goal by itself. It's a tool, an instrument, not the goal. Nowadays, it seems to be that smart grid, the goal seems to be to deploy a lot of communication or whatever. This is an instrument, not a goal. If we don't use them, it's useless. It's a wasting of money and time. So, going back to the energy storage, we need energy storage because otherwise we will not succeed in this challenge, which is energy delivery in a sustainable manner. So I think, of course, what Giannaki said about this regulation, for instance, European Union now is in a consultation project because they are announcing for next year new rules for wholesale market and local market, retail markets. So regulation is also very important. It's a key factor also, because otherwise there is no. The problem is that we are learning by error and trial process. We make mistakes and we correct, because the design of wholesale market nowadays is not smart. The design of this European single market, interconnected, is not smart. It's a juxtaposition of many regional markets or national markets. A chaos. I don't like the way they are implementing this wholesale European market. And the energy union is fighting against the interests of every country. So in this sense, I'm afraid that Europe will never be like USA. Because USA, there is a federal government with enough power to implement all policies. In Europe, there is another challenge, which is agreeing that the energy policy should be unified and is as important as monetary or financial instruments. So
I only would add that I agree that smart grid is not the goal. The goal is other one. The smart grid is just the tool, the way. For me, I think the goal mainly is energy efficiency on one side and consumer engagement on the other side. And to get consumer engagement, the consumer needs information. That's basic. If you don't have information, you cannot decide, you cannot take your own decisions. And to have information, we need smart systems, because the smart systems are the systems that will provide information to the customers so that the customer can get engaged, can have the decisions when to use the energy in the cheapest moment. Now in Spain, we are facing new tariffs for electricity, depending on the time of the day, of the hour. So if you are aware of what time the energy is cheaper, you can connect your devices at this time, or you can program your devices. But for all this, you need information. And that's why we need smart systems, just to have information and to have the consumer engagement. And the final goal is, for me, energy efficiency, basically.
Talk about I talk too much, so I talk too much. So please.
No, I don't. Do you want me to answer it or? I understood. I had that in mind a little bit. It crossed my mind when I received the list of questions earlier today. Even questions like that crossed my mind, but I classified it under the next question, which deals with the open problems. It's not an enabling technology per se. So my previous answer focused on what do you think are the key enabling steps to realize the vision of a smart grid. So if you ask me what are the open problems, my number one in the list is basically integration of the power grid with other critical infrastructures. And that includes nuclear, biomass, data centers, and the like. So the integration of other critical infrastructures is an open problem, and people, even right now as we talk, people just scratch the surface of how can we benefit when we integrate resource allocation problems of the power grid with the gas grid. Very much of interest for the Russians, because they have a gas pipe and they care about how can we complement, where do we use gas, where do we use electricity and the like. So nuclear plants is along the same lines in my mind. It's another form of resource, it's another resource. How do you allocate them judiciously is of interest. So my first question, do you want me to go on with the open problems or somebody else to address the question?
Maybe if anyone else wants to say something specifically.
On the nuclear?
Customer role, right?
No, go ahead. I'm done with
Okay.
the
Well, these are two topics very important. I could stay talking for 2 hours. So, but anyway, I think there are two different kinds of countries those like Germany, which they think that they can get rid totally of nuclear energy, and I don't think so, anyway, in the short time at least. So they plan to abandon all nuclear energy by 2022 something. But they need a huge HVDC corridor from the north to the south, where they have the major load centers. And those corridors should be ready earlier. And I have read today in this energy post, very popular energy post today, when I was coming here in the taxi, that there is some delays, significant delays in the deployment of those whole corridors. They will be ready not earlier than 2025. So I'm afraid that Germany will have to postpone closing the nuclear energy. So it's very difficult. I mean, they have plans very ambitious plans to get rid of fossil fuels, but they are currently, in spite of those 80 gigawatts of wind and solar, they are still using 70% yearly of fossil fuel or nuclear. So it's very challenging and difficult for Germany to, for instance, to get rid of nuclear and coal from now to, according to their plans. So they will have to reconsider those plans for sure in the next few years. Other countries like UK, for instance, they on the contrary, they're planning to deploy new nuclear stations. The problem I see is that all those nuclear stations are very expensive. Right? The main reason why nuclear stations have not been deployed, but the initial investment capital is very huge. And there are no, probably financial institution capable or able to, willing to finance this project. So it's very, very expensive to deploy a nuclear energy. And what is happening now is that this increasingly higher amounts of renewable is making conventional units to work less regularly. For instance, in Spain, combined cycles are working now less than 1,000 hours a year, 900 hours, less than 1,000 hours a year, which is horrible for this investment, because the owners of those combined cycles have trouble. They want to dismantle and to close those combined cycles. It's horrible. Because there are, the base load is being filled by the renewables. So, and those combined cycles are only used on peak, so very, very few hours a year, right? So, I'm sure, in my opinion, in the future, the energy mix will be a nice combination of renewables and nuclear. Not the nuclear generation we already have, which was designed 60 years ago and based on military submarines. I don't think this current generation Arriva is promoting in Finland and France is the future. I think this is the past. So future nuclear reactor, fission reactor, will be based on different technology that we don't know yet. For instance, thorium salts or whatever. I don't know. I'm not an expert in nuclear energy, but I'm pretty sure that in the future we will have a nice combination of renewables and nuclear, some kind of nuclear. Regarding nuclear, regarding the role as customer, your question is very important. Are we just waiting for, we have a hourly price, energy price every hour. Thanks to this smart meter, we may have, like in Spain, for instance, an hour the day before, we may have the signal for the price for every hour for the next day, okay? So I don't think the individual customer will modify so much their way of living because of this. I have some friends in Canada, for instance, in Canada, they have this kind of device at home that helping them to control the air conditioning and everything, to this model predictive control of this kind of thing to minimize the cost they pay for the energy. And they complain that, okay, my wife doesn't want to, the washing machine is, you cannot wait, in my opinion, this role should be played by an entity which is not probably yet fully developed, which is the aggregator. We should talk in the future about the aggregator. And the European Union is considering in the new regulation this role as an intermediate between, wholesale markets and the individual customers. So we, in the same way as the distribution system operator will play a similar role to the transmission system operator, in the same way there will be local markets which will play the same role as wholesale market, but at the local level, municipality or whatever, microgrids or whatever, several layers. And then those local markets will balance the renewable energy in the generating a distributed manner. And then the wholesale markets will balance the unbalance. Will be, So there will be a hierarchy of elements, of agents, and in between there will be a new agent, which is aggregator, that will take care of your own consumption.
I talk about personal experience. I have a house which is heated by electricity, and the water is heated by electricity. So 75% of my electricity bills comes from these two. So I would be really interested in looking at when do I heat my water and when do I heat my house. So there are of course different kind of customers even in the domestic market. So some people, when they just use their appliances based on electricity, probably don't care. I mean, the savings per month could be maybe 2, 3, 4 euros. But they probably don't care. And as you mentioned, the aggregator or some kind of home energy management system, which basically is doing the things for you, would be the thing. Well, the innovations that we will probably see in the few years. And we see them already in some countries where you can program. For instance, in Finland, we have spot pricing where you can buy your energy, well, use your energy based on an hourly price and all that. So you have different kind of contracts already available in Finland. But this home energy management system, they just don't sell. And but for me, for instance, it would be wise. Well, I have a sort of like nighttime and daytime and different prices for energy. I chose that kind of contract so that I heat my water and heat my house during the night because I get 3 cents per kilowatt hour. So and during the daytime it's 7 cents. So it makes sense, right? So it depends on what kind of customer you are. For my kind of customer, yes, it makes sense to look at when to use the electricity and when not. But for many, no. And as for the nuclear question, I come from Finland, and we have just made a decision to build yet another nuclear power station. And my prediction is that the big question that we nowadays face with the nuclear energy is, of course, the waste. And I predict that some kind of new technology, again, blue sky, will be developed when this particular waste is the most wanted fuel that you can ever have. So this, again, will solve itself in due time.
Okay, guys. So maybe I think we're keen for close of the session. So maybe I can ask you to want to talk a bit about what we see as open research.
Yep. I already started by saying my first topic would be integration of power technologies with other kinds of technologies. Then what I have marked are advances both in controls and communications, as well as in energy systems. So, admittedly, these are influenced by my group's interests, the things that we're working or will be working down the road. And on the control and communication aspects, I think major advances should be made on smart power inverters and off-the-shelf controllers. Now, at the device level, clearly there is a need for more efficient batteries and efficient storage solutions at the device. At the system level, I believe that a lot more things can be done in stochastic resource allocation, because anytime you incorporate renewables, stochasticity comes, with it in any optimization problem you formulate to optimize the operation of the grid. In addition to resource allocation, stochastic resource allocation, I would see open problems in operation control protection enabled by the heterogeneous sets of data that have huge volume. That's another system level advance people have not looked at. for example, to handle at the system level, mitigate and cope with electromechanical oscillations. I also expect to see much more security constraints being incorporated as the web is integrated. And certainly we're going to see, major advances at the distribution level, where millions of nodes with flexible loads will be deployed and cohesively operate as a distributed infrastructure. And finally, big data analytics for monitoring purposes primarily. So, once more, advances at the control and COM levels, advances at the devices and the system levels, along with the distribution and big data for monitoring.
Okay, so that basically covers the technical part.
That's the only thing I know.
One of the key issues Roy already addressed in the question here is how to a person, a customer, a prosumer adopt the technologies that we are. So a lot of research on human behavior would be required to make this prosumer role desired one in a future society. Another thing is that we have a lot of players in the marketplace already, but we start to see a new type of players like aggregators coming into the play. So what type of future business models do we need to fuel the whole ecosystem that we will start to see in the future in this field? That is also a open question, and there might be also new cases when you start to see totally different kind of business models, not like your ordinary ones, but the ones that are based on shared resources. So these Uber type of business models may start to appear in the future, so that some people may rent the distribution networks, and the contracts may start to be different. For instance, you just buy nuclear energy, or you just buy wind energy, and of course you are using the electrons that are close to you, but so the different kind of the rules may change in the electricity business as well in the future. Of course, there is this physical restraint of the power grid, which is normally owned by someone, but I mean, the cars are owned by the individuals that Uber is using. So basically there is a potential for totally new kind of business models also in the future.
Okay, I think the question probably is not well posed. I mean, it should be, what are the open research problems that need to be addressed to fully benefit of the smart grid technology, to get to, smart grid will be adopted anyway. I mean, it's being adopted very quickly. So it's any technology which is economically feasible will be adopted. So no question, no doubt. So how can we benefit? Answering the other question. So open research problem to improve. I mean, how can we benefit? The problem is. Unfortunately, most problems nowadays are economical, not technical. I mean, for instance, why do we have so much photovoltaic now and we didn't have 10 years ago? Because the price has been divided by 5 or 6 of the PV modules. So something similar happened with wind energy. They say that every time the production doubled, the cost reduced by 16 to 20% or something like this. They say that, the gurus say that this will happen also with energy storage. When energy storage will double, the price will reduce between 15 and 20%. And this is the major problem nowadays, more than technical. Of course, this is related to technical improvement, of course. So there is a need for much research in materials, technology which we are not calling here in this forum smart grids. But anyway, we have to develop this Another thing is efficiency. Manuel Jesus said that efficiency is very important, and I think we are still missing the whole potential of cogeneration. Cogeneration is very important in the Nordic countries, in Finland, in Denmark, but in the southern company, in Spain, for instance, amounts only to 12% of the energy production, cogeneration, which means that we are significantly reducing the efficiency of the generation system. The average efficiency worldwide of the generation system is 31% electricity production, according to international energy data. So we should improve the efficiency. We should take advantage of new technology for cogeneration, like micro turbines, for instance. Micro turbines are modular, can be deployed everywhere. They are very efficient for simultaneously producing heating and electricity. So I think micro turbines should be something that should be, so investigation on how to integrate this in local markets and this balancing this renewable energy at the local level. And finally, Manuel Jesus properly said that there are basically three goals: is efficiency, integration of renewable, and allowing demand-side management. But I would say another foot of this smart grid, which is distribution automation. Distribution automation is a very old acronym and a very old word, topic of research, but couldn't be fully realized because we lack the technology. I mean, 30 years ago we had analog communication and very expensive switchgear and whatever. So, but now distribution automation with this very cheap communication system can be a reality and is open to research. Like, for instance, situation awareness, restoration of service, how to automatically perform. Distribution operators are very. I mean, it's very difficult for them to handle a blackout because they have to manage people going out and everywhere. So it's very difficult. Automatic restoration of service, for instance, is still open to self-healing. I mean, switching the topology of the distribution network to isolate the faulty system and then feed the service, the energy through the other way. I mean, this kind of distribution automation, which is a very old topic, but is not well developed yet because we lacked the technology. So, and that's all.
Last word to industrials.
I just want to point out perhaps not a technical problem regarding the research problem, but perhaps the planning. One of the problems I see is that nowadays we say there is a little bit of uncoordination. Now we say that the smart metering infrastructure is the basis of the future smart grids. But when we deployed the smart metering infrastructure, we did not design those infrastructure for the future smart grids. We just designed them for smart metering, which is a different goal, a different scope. So now perhaps we are suffering that the smart metering.
They are not smart at all.
No, they are smart.
No, they are not smart enough. They are not smart enough.
They are not smart enough for the grids, but yes for the smart metering. So that's why I say that there is perhaps a little bit of uncoordination. When the smart metering were deployed was because there was a pressure by the government to deploy very quick. There were no standard, the technology there were not good technologies, so, but in any way, the companies had to deploy because they were obliged by the government, by the legislation to deploy. So they had to deploy what was available at that time. And now we want to implement smart grids over infrastructure that perhaps were not well planned to support all these new smart grids. And this is a little bit of uncoordination that I think should be solved in the future.
I agree.
Okay, so any questions, any last?
Right. So, here that one of the goals is to have more renewables. An example that Germany cannot have more big would be 2% to 60%, as you said. And the thing about renewables, let's say wind, is a big thing, is that they are intermittent. So, looking from the power systems engineering
spare capacity. Spare capacity.
Spinning reserve. It's expensive. It's usually when we're talking about wind that's going up and down around rates really fast. You need usually gas units to keep up with that, or diesel units that are small and fast, and they're expensive. And again, we talked then about storage of renewables, but storage is also again expensive. So you need to have for renewables storage and spinning reserve. That's not cheap.
Yeah. I mean, yeah, it's a good question. I mean, the current levelized cost of electricity from photovoltaic and wind is lower than natural gas. Believe me. I mean, according to many data, the Ecofis, for instance, the LCOE, they call levelized cost of electricity from photovoltaic and wind, particularly offshore wind, is lower than natural gas. But if you add the need to store the energy for instance, in solar thermal station, they usually use molten salt to store energy for 6 hours, 7 hours. If you add all those costs, then it's not as cheap. So, but hopefully, if the price evolution, the cost evolution of energy storage system, we already have many of them, by the way, in Europe. We have this pumped storage, hydro pumped storage. But if the combined cost, the added cost of energy storage and renewable is similar than to the fossil fuels, then we have solved the problem in this sense. It's difficult. This may be something in the future. And technically there is no problem, because the new power converter, we have not talked about power electronics here, but the new power converter, for instance, make it possible for photovoltaics to contribute to ancillary services. They can contribute to voltage regulation very easily. The new voltage converter, no problem, voltage source converter. And if they have energy storage behind, they can also simulate synchronism, as you probably know. So if we can provide ancillary services, including frequency regulation if we have energy storage, which is something which is already a reality in some new thermal station and photovoltaic systems. Abengoa, for instance, is deploying in Chile a system like this. So the main, as I said at the beginning, the main pending issue is cost reduction, not technical.
Smaller than what the technical is. A lot of companies say that we want to cover 2020 that we need 50% or 100% of renewables. But then how are you going to cover 100% of the about gigawatt-hours, terawatt-hours of power renewables when you don't have them available for 2 or 3 days, 4 days, as much as you need? The storage cannot be that big, and even if you have that big storage, because of steam cold compressors, for example, to pool big storage and get around to the efficiency 60-something%, which means you need to generate 50% more than you need for the next 4 days.
Yeah.
It's not practical, it's not technical.
Yeah, that's why I believe we will have nuclear energy also.
If I may just interrupt here, so we agree that all of the resources are not correlated daily, but I can remember someone mentioning big data before. Does anyone know about a study that shows the minimum amount of energy that will always be available, like statistically speaking? Because I don't think of any way in which we would have no renewables. And I think also designing the reserves, you say, well, I installed wind farms, I'm going to have for each gigawatt, I install 200 megawatts of backup or whatever. But if you consider, we said before, we should consider the system as a whole. Then if you make statistic big data study of the system as a whole, then you know what sort of resources available. So instead of saying, well, 1 gigawatt of wind power, 200 megawatt of backup, for example, you say, well, I have all of this installed, 2 gigawatts of sun, and so on, dispatched all around the countries to make measurements. And I don't know if anyone has been doing studies of the generation as a whole of renewables, saying that in the end, if you mix it well enough, maybe the need of backup is really much smaller, and that's sort of 100% renewables or as close to that as possible. It's maybe not so far from the peak if we are able to shift different enough, and that's also what this market is about, shifting different wait times. Does it make sense?
Yes, but for this you need a very well interconnected transmission grid.
That's what
You need,
it is.
and
A
yeah, so
lot of management.
yeah, and this is a problem because there is a huge social opposition to build new infrastructure. Underground cables are very, very expensive, over 5 times or 8 times as expensive as overhead lines. Nobody wants overhead line, not in my backyard, so this is a problem. So in order to achieve, for instance, it would be nice if we had Asia and Europe fully interconnected, and then taking advantage of the time different, sun different, we could benefit from, solar energy from North America, for instance, I don't know. But this is very difficult.
But even in this case, on the regional case, like, do we have any study based upon measurement data when it's already available without adding any interconnection? I haven't seen anything like this. So even like not thinking about what happens if we interconnect or not, but just thinking about what we have at hand and what we can do. Because maybe there's already a lot to just do what we have. And if we just like get the data and get the knowledge out of it. And I don't see this.
On that topic about having globally available resources, an example of UK was from some renewables, and check realistically if you can transfer that energy down to, let's say, London when you have an excess of power. It's not practical, technical, economical viable unless you create new lines, very high transmission lines. And the whole point of having smart is let's use communication instead of building new grids or getting new lines because it's cheaper. So if you counter that point, you're trying to transfer energy in big geographical distances. So it's not a good solution if you have localized generation consumption, distributed generation, that's what it's do.
Do you want to make a final comment?
No, it's not a final comment. I would have kept my mouth shut. But there is one reason I will make a comment and disagree with the comment that was made earlier. We are here in an advantage group, right? We have students early in their research careers and they are engineers. I would not say that the open problems are non-technical and they are only economical. We don't have an audience of MBAs here. There are a lot of fun research that you can do, and I can assure you that what is being used nowadays, both on the monitoring and the optimization of the power grid and the associated technologies that are emerging, are far behind from the state of the art in optimization. So getting tools that are popular in machine learning, optimization, communications, networking, and bringing them to bear with the problems of the power grid offer exciting opportunities for graduate studies and postdoctoral research. That's my 2 cents. In addition to economical stuff.
Okay, guys, so maybe we'll call it to a close there. So I want to say 2 things. So first thing is, I look forward, the panel has told you all the issues and things to think about, so I'm looking forward to seeing the answers in 2 years' time when you will finish your PhDs. I'm sure these guys will be